Alright guys, we're going to go over the support material for section 2.1 for college algebra. So section 2.1 in college algebra is concerned with graphing equations or graphing functions. Okay, so this is a little bit of introductory material. So it says an equation is a number sentence that says that the expressions on either side of the equal sign, so you guys know what the equal sign looks like, represent the same number. Or basically, you have the same thing on both sides of the equal sign. Okay, so a very simple equation. Okay, yeah. A very simple equation would be something like 10 is equal to 10. Okay, we've got the same number on both sides of this equation, or on both sides of the equal sign, but we're also going to see equations that have variables in them. So something like this, 4x plus 1, we'll say is equal to 13. Okay, this is an equation as well. It's got an equal sign. Many times, though, equations like this, in which there's a variable, we're interested in trying to figure out the value of that variable that would make the left side become equal to the right side. So in this case, if x represented the number 3, that would what we call solve this equation. That would make the left side would become 13, because 4 times 3 is 12, plus the 1 would give us 13. So we'd end up with 13 on the left side, 13 on the right side. Okay. I'll actually put that down here, that x is 3. Or, well, actually I'm going to put x is equal to 3. Okay. And so a solution to an equation like this is just a single number. But we're going to see equations that have more than just one variable. So this equation only has one variable. What about, let's try another equation. Maybe 2x plus, we'll say, I don't know, just y is equal to, we'll say 7. Okay. So a solution to an equation like this is going to be a value for x and a value for y. That would make this left side become a 7, so that you have a 7 on the left side and a 7 on the right hand side. But as you can see, since we have two variables, the solution would end up being two different numbers. We'd have a number for x and a number for y. So x might be 3 and y might be 1. And you could check this. You plug in 3 for x, 2 times 3 is 6. If you plug in 1 for y, you get 1. So 6 plus 1 is equal to 7. Okay? So the solution to this equation consists of two different numbers. And this is what we call an ordered pair. And that's what this next piece talks about. Okay. All right, it says the replacements for the variable that make an equation true are called the solutions. And the set of all solutions is called the solution set. So this equation right here, there's only one solution. It's just the number 3. Now this equation, on the other hand, has actually more than a solution. And by the way, a solution in this case is this pair of numbers, the 3 for x and the 1 for y. But it turns out there are values for x and y, other values that would make this true as well. So the solution set for this equation would consist of more than just one of these ordered pairs. It says when we find all the solutions, we say that we've solved the equation. If an equation has two variables, the solution is called an ordered pair, and it's usually written like this. Okay, so like from above, if x is 3, then I put a 3 in for x, and then if y is 1, then I plug a 1 in for y. They call this an ordered pair because the order matters. You don't want to put the 3 over here and the 1 in front, because the value for x has to go first and the value for y has to go second. Now I want to point out that you'll see equations that don't always use x and y. Okay, they could use a and b. So it really doesn't matter what the variables are. So if this was, let me change this up a little bit. If this were 2a plus b is equal to 7, the solution's still going to be the same, except your ordered pair would be written with the a first and the b second. Okay, usually they're in alphabetical order. So you'd plug a 3 in for the a and a 1 in for the b. So that's just an example. Okay, now let's look at an example 1. It says determine whether the given point is a solution of the equation. Now these two right here are ordered pairs. We can also call them points because when we plot an ordered pair, we plot it on what we call a coordinate plane, or more specifically a Cartesian coordinate plane. Okay, and so you have an axis for the x value and then another axis, a vertical axis for the value of y. And so these ordered pairs, when plotted, are known as points or appear as points on this two-dimensional plane. We'll look at that here in a minute. All right, so to determine, we've got two ordered pairs here. To determine whether either of these are solutions to this equation, we're going to plug these values in for x and y, okay, respectively. So this first one, let me zoom in a little bit. Our first order pair is -1, 5. So we know the value for x is -1 and the value for y is 5. So what I need to do is rewrite my equation right here. So y is equal to 4 minus x. And I need to plug these numbers in for x and y. This is where you need to be careful. I would say that anytime you're substituting numbers into variables, always encapsulate those numbers with parentheses. So when I rewrite this, I'm going to plug the 5 in for the y. The minus sign is part of the equation, and I'll plug in the -1 for x. The reason I like to do this is because right here, you don't have to think, well, is this minus sign actually a negative? Is it actually this negative here? No, it's not. This minus sign is part of the equation. When you plug in the -1, then you get two negatives right here. Okay, and these two negatives are going to become a positive. So that's why I like to do that. It helps me keep track of these negatives. So I know a lot of people have difficulty with that. All right, so the 5 I'm going to bring down. I don't need it in parentheses anymore. And I'm going to change these double negatives to a plus. So if you remember from pre-algebra, subtracting a negative is the same as adding a positive. Okay, so that becomes 4 plus 1. So we'll keep working here. 4 plus 1 is 5. So we had 5 on the left side and we've got 5 on the right hand side. And this is a true statement. Okay, so I'm going to put a check mark there. So what that means is that first ordered pair, -1, 5, is a solution. You can always check to see if something is a solution, guys, by plugging it into the equation. All right, now let's try the second ordered pair. So it is 0, -2. So in this case, our x is 0 and the y is -2. So I'm going to do the same thing, recopy my equation, and I'm going to plug in -2 for y equals 4 minus, and then plug in 0 for x. All right, now in this case we don't have any double negatives here, so I can recopy this without parentheses. Okay, and we'll keep going. On the right hand side, 4 minus 0 is just 4, and so we've gone as far as we can. We've got to determine, is this ordered pair a solution? Well, when we plug these numbers in for x and y, it's giving us this statement right here. This is not a true statement, guys. negative 2 is not equal to 4. So that's a false statement, and because of that, we can say that that ordered pair, and I'll write it, 0, comma, negative 2, is not a solution. Okay. All right. Now let's move on. It says many times we're going to have to solve equations. Okay, so if you look back up here, I just really solved these in my head. Like this one right here, I could just kind of look at it and see that x has to represent a 3 in order for this to turn into a 13. Okay, but many times, guys, you can't just look at these and determine what the solution is going to be without doing some work. And that's what these two principles talk about. I'm not going to go in great depth here. I'm just going to mention them. Hopefully you're already familiar with these. You should be. The addition principle and the multiplication principle. The addition principle, basically what it allows us to do is that if we have, well, let's just look at that equation from above. When you solve an equation, you're trying to isolate the variable. You're trying to get the variable by itself. So at the very bottom of this, if I have it completely solved, I need to get a statement that says that x is equal to some number. In this case, it's going to be 3. And so what you do to solve this is you have to get that x by itself. So we have two terms right here. So what you have to do is first try to get rid of the term that doesn't have the x in it, so the 1 in this case. So this is where this addition principle comes in. It basically says that to get rid of that 1, since this 1 is getting added to the 4x, you can do the opposite. You can take the 1 away, or in other words, you can subtract it. Okay? But what the addition principle says is that if you subtract 1 from the left side of this equation, then you've got to subtract 1 from the right-hand side, because this equation is like a seesaw. It has got to stay balanced. If I just subtract 1 from one side, then it becomes unbalanced. One side becomes heavier than the other one. So I've got to do the same thing to both sides. You guys have probably heard this before. And so what happens is, on the left-hand side here, 1 minus 1 becomes 0. So we have nothing left from that term. All we have left is the term 4x. This is called the variable term. So you can bring that down. You bring down the equal sign. And then you subtract 1 from the 13. So 13 minus 1 is 12. Okay? So you get to this step. Now with the addition principle basically says that you can either add or subtract any number you want from both sides of the equation, and the equation will stay balanced. But when you're solving these equations, you don't want to add or subtract just any number. You want to try to eliminate the number, or you got to think, how can I eliminate this number? If it's a plus 1, you want to subtract 1. Okay. All right. Now we're at this point. We've got our x term by itself. We've got to get the x by itself. So that's where this next principle comes in, the multiplication principle. It basically says that we can multiply or divide both sides of the equation by any number. Okay? But you've got to be judicious here. So if we're trying to, finish this out, we've got 4x is equal to 12. Well, this 4x right here actually means 4 times x. Okay, so we're trying to think, well, we want to get the x by itself, and we've got the x getting multiplied by 4. So what is the opposite? How can we undo that? Well, the opposite of multiplication is division. So using this multiplication principle, remember the multiplication principle means we can either multiply or divide. So in this case, if we divide both sides by 4, the equation's going to stay balanced because I'm doing the same thing to both sides. But on the left-hand side, when you divide 4 by 4, you get 1. And so this becomes 1x, or 1 times x, which 1 times anything is itself. So 1 times x, we typically just write as x. And lots of times, guys, what people will do is say, well, the 4's divide out, so they'll cross those out. Okay, so you'll see me doing that throughout in the course. And so we're just left with 1x. We bring down our equal sign, and then we've got to divide the right-hand side by 4. So 12 divided by 4 is 3. And so this ends up being the solution. But you can see we had to use both of these principles. All right, so hopefully you should already know how to solve these linear equations, guys. If not, come see me. I can give you a video from my transitional algebra class where I go over it in much, much more detail, okay, from scratch, in other words. So essentially what we did when we solved this equation was we just undid all these operations. We just did every single operation backwards. We went in the reverse of what we call the order of operations. All right. The reason this is important is because in section 2.1 we're going to have to graph an equation like this. And guys, the easiest way to graph, and you'll see why later, is whenever this equation is solved for y. So what that means is, instead of having it written like this, 4y plus 3x equals 8, is we want to move some of these terms around so that we just have the y on the left-hand side and everything else on the right-hand side. Okay. And so to do this, we've got to use these two principles that we talked about. In other words, instead of solving this one for x like we did above, we're trying to solve it for y. Okay. So this is how it's going to go. Got 4y. I'll recopy the equation. Whoops. 4y plus 3x is equal to 8. The first thing we want to do, if we want to isolate the y, is we need to get rid of the x term. Okay, so we need this 3x to go away. Or we need to move it to the other side. Now let's look here. The 3x is getting added to the 4y. So to undo the addition, we need to subtract. So what I'll do is subtract 3x. But I've got to do it to both sides. And so what happens, 3x minus 3x is 0. Okay, so we're left with nothing right there. The only thing we're going to have on the left-hand side will be our y term, the 4y. So that's what you bring down. You can just cross out those terms, or you can think that they cancel. Basically, they turn into 0, so they're gone. Now, what happens over here on the right? We'll probably talk about this some more in the support material. You cannot actually subtract 3x from 8. You could subtract 3 from 8, but not 3x. These are what we call unlike terms, because one of the terms has a variable and the other one doesn't. So what we do in this case is we just rewrite these. Okay. Now, technically, the order doesn't matter. You could put 8 and then minus 3x, but it's better to put the variable term first. So I'll put the negative 3x first, and since this is a positive 8, you'll put plus 8. This will make more sense later on, why we want to put the x term in front of, this is what we call a constant term. Okay. All right, now we've got the y term by itself, but we've got to get the y by itself. This is where we're going to use the multiplication principle, because the y is getting multiplied by 4. So to undo that multiplication, we've got to divide. But again, we've got to do it to both sides. So this is the way it's usually written. Divide the left side by 4. And since the right-hand side has 2 terms, you've got to divide this whole thing by 4. So what I do is I just usually put a division bar under both of those terms. Okay. And if you had 3 terms, then you would divide all 3 terms by 4. So on the left, 4 divided by 4 is 1. So that leaves us with just y. So we got it by itself. Now, on the right-hand side, you're going to look at these two numbers and see, can you actually divide them by 4? Well, negative 3 divided by 4, you could try this in your calculator. We'll be using this calculator throughout this course. You say negative 3 divided by 4, and you get a decimal. Usually if you get a decimal, that means it's probably better just to leave it as a fraction. We don't care too much for decimals, guys. So that means I'm going to leave that one as a fraction. And so usually you'll put the 4 just under the negative 3 and you'll put the x out beside it. Now what about the next term? Can we divide 8 by 4? Yes, it goes 2 times. So that's going to leave us with a plus 2. Okay. So when we solve this equation for y, we get y is equal to negative 3/4 times x plus 2. Now I want to point out, this equation is the same as what we have up here. Okay? We didn't violate any laws here. Whatever value for x and y would make this top equation true, those same numbers will make this bottom equation true. The relationship between x and y is the same in both of these. But when the equation is written like this, when it's solved for y, it makes it easier to graph. And that's why we need to know how to do this. Okay, so that's going to be our answer. And we solved it for y. Alright, so now let's kind of gear up into graphing mode. This says the Cartesian coordinate system. So I spoke of this earlier. Let me point out that, let's go back to this equation right here. This is what we call a one-dimensional equation because there's only one variable. And if I wanted to graph the solution to this equation, it's just the number 3. All I would need is a number line, okay? Something like this. Basically just the x-axis is all I would need. I would just need the number line, and all I would do is I would put a point at 3, and that's it. This, what I have graphed here, would represent the solution to this equation right here. But what about this equation? This equation has an x and a y. So that's where this two-dimensional coordinate system comes in. Not only do we need an x-axis, we need a y-axis as well. Okay. We'll be using this throughout the course, by the way. All right, and so what you do, so let's say that these 4 ordered pairs are solutions to some equation. Okay. And what we want to do is graph those solutions or plot them. So remember, these are called ordered pairs for a reason. This first one, 5, 3, that means that x is 5 and the y is 3. So the way you can do these is you're going to start right here in the middle. This, by the way, is called the origin. This is where the x is 0 and the y is also 0. So let's look at the x-axis. Values of x that are positive are going to be over here to the right. Values of x that are negative are to the left. Values of y that are positive are above the x-axis, and values of y that are negative are going to be down here. Okay? And these number lines are called axes. So to plot, you're going to start in the middle, and you're going to look at these numbers as the directions on where to go. So if x is positive 5, then you're going to move to the right 5 places. You're going to stop, but you're not going to put the point here because we're not finished. We need to take into account the value of y, which is 3. So that means since 3 is positive, we're going to go up. And now we're going to stop, and that's where we plot the point. So you can see that when that's done, that point is above the x-axis at 5 and to the side of the y-axis at 3. We can even label it. Okay. And that's how you're going to do the rest of these. Negative 4 comma 1. So again, you would, let me get a different color for this one. So you'd start right here in the middle. Since the x is negative, we're going to go to the left 4. So you go to the left 4. Well, let's see, 1, 2, 3, 4. And then the y is positive 1, so we go up 1 and we stop. And that's where we plot our point. And that is negative 4 comma 1. Let's try another one. How about negative 7 comma 0? Start at the origin. The x is negative 7, so we go to the left 7, we stop. But the y is 0, so that means we're not going to go up, nor will we go down. So we're going to stay put. So this point, guys, lands right on top of the x-axis. This is actually what we'll call later, refer to later, as an x-intercept, because it's a point that intercepts the x-axis, or lies on top of the x-axis. And then the last one here, 0 comma negative 2. Oh no, 0 comma 2. Well, in this case, x is 0, so we still start in the middle. But if x is 0, we're not going to go to the left or to the right. We're going to stay put. And then we're going to look at y, which is 2, which is positive. So we're just going to go up 2, and we're going to stop. Okay. So this particular point lands on top of the y-axis. This is what we refer to as a y-intercept. And we'll discuss these more later. Okay. All right, so hopefully this will kind of prepare you for 2.1 when we look at graphing some both what we call linear and nonlinear equations. And we're going to do it by plotting ordered pairs, or plotting points, in other words.